MOSFET and its analysis, under which we have studied the syllabus of MOSFET and its analysis is, I am reading it. Enhancement MOSFET, construction of MOSFET we have studied, characteristics of MOSFET we have studied, DC load line, that means load line of the signal if DC is connected, then AC equivalent circuit of the MOSFET we have studied, different types of parameters such as output impedance, input impedance, transconductance, effect of temperatures, and so these parameters and parasitics we have studied. Then we have studied non-ideal characteristics such as finite output resistance, body effect, sub-threshold conduction, breakdown effect, temperature effect, effect of W by the L, that is width to length ratio. Then common amplifier and analysis we have studied, source follower circuit diagram, comparison with common source, frequency response for amplifier we have studied. Now we will learn a unit number 2, that is MOSFET circuit. Unit number 1 and unit number 2, these two units are very important because unit 1 and 2 carries 30 marks in semester examination. I hope this in semester examination will be a offline examination. Everything will be fine and there will be a offline examination based upon unit number 1 and unit number 2. It is very easy to learn unit number 1 and 2. Instead of BJT only, MOSFET is replaced. That means what are the characteristics of BJT? All characteristics are available with reference to MOSFET. Everything, this whatever circuit we prepare using bipolar junction transistors, same circuits we can build using MOSFETs. But MOSFET requires less power consumption, or say power consumption in MOSFETs are less and power consumption in BJT is more. The second difference between MOSFET and BJT is that BJT is bipolar junction transistor, whereas MOSFET is unipolar junction transistor. That's why heat generated is very less. Even space required is less in the MOSFET, whereas space required in BJT is more, and hence MOSFETs are more preferred. In a VLSI technology, lakhs of transistors, lakhs of resistors, lakhs of diodes are manufactured on a single 1 centimeter by 1 centimeter chip. It is not possible without MOSFET or low space. Using BJT we cannot manufacture lakhs of transistors on a single 1 centimeter by 1 centimeter chip. But it is possible using MOSFETs, that is VLSI technology, very large scale integration technology. And so MOSFET, recent days transistors are replaced by MOSFETs. Every company, a manufacturing unit, is replacing transistor based circuits by MOSFET based circuits. In a old eras, during 90s, there were transistor, 90s to 2010, there were transistor based circuits, but after 2010, a MOSFET based circuits has occurred. And so whatever circuit is available using BJT, all circuits are available using MOSFETs, and hence in a MOSFET, enhancement type of MOSFET is there in a syllabus, and all these characteristics, then construction characteristics, DC load line, AC equivalent circuit, different parameters such as output impedance, then input impedance, temperature effect, all these is having equivalence to BJT. So if you are well familiar with BJT based analysis, then it will be easy for you to understand MOSFETs. MOSFET circuit we will learn in unit number 2. In unit number 2 we will learn MOSFET circuits. MOSFET can be used as a switch. Then what is syllabus of MOSFET circuits? MOSFET as a switch. I will read a syllabus of MOSFET circuits. MOSFET as a switch first, then MOSFET inverter. MOSFET can be used as a resistor. MOSFET can be used as a diode. That means active components are used for manufacturing passive components. So MOSFET can be used as a resistor also, and MOSFETs can be used as a diode. Resistor is a passive component. That passive component can be manufactured using MOSFET, which is active components. So using active components, passive components can be manufactured. Why this situation has occurred? Because passive component requires more space on IC manufacturing, whereas active component based passive components means CMOS based resistor requires very low space on the IC manufacturing, and that's why CMOS based resistors plays important role in very large scale integration. Then there in a syllabus current sink and current source. The same you might have studied using BJT based current sink and current source. Then current mirror, a very simple circuits are there, a very simple circuits using MOSFETs are there in the syllabus. Okay. Current sink, current source is there. Current mirror is also there. Then 4 types of feedback amplifiers are there. Effect of feedback, voltage series, current series feedback, amplifiers and analysis, Barkhausen criteria, Wein bridge and phase shift oscillator. So these are the circuits we are going to learn using MOSFETs. So unit number 2 is based upon circuits. Which are the circuits we can build? We can build inverters, we can build resistors, we can build diodes, we can build current source, we can build current mirror, we can build feedback amplifiers, we can build oscillators using MOSFETs. So MOSFET plays very important role in electronic circuit analysis or electronic circuit manufacturing. Okay, this is unit number 2. We will start with MOSFET as a switch today. MOSFET as a switch. So I am sharing a screen. Do you find my screen? MOSFET as a switch?
No, sir.
No, you don't find. I am sharing it again. I am scared. MOSFET as a switch, MOSFET as a diode, and MOSFET as active resistor. MOSFET digital circuits in late 70s as the era of large scale integration and very large scale integration began, MOSFET became the fabrication technology of choice. I told you that MOSFET is using less power consumption, or power consumption in the MOSFET is less, and that's why since 70s MOSFET came into picture. Then second point that I want to read over here, later the design flexibility and other advantages of CMOS were realized. CMOS technology then replaced NMOS. NMOS means N channel MOSFET at all level of integration. Now let me to tell you, NMOS means N channel MOSFET and CMOS means complement MOSFET. Complement means which is manufactured using NMOS as well as P type of MOSFETs. So it is complement MOSFET, or which is manufactured using N as well as P type of MOSFET. Why CMOS technology? Because power consumption is less in P MOSFETs. Then third, the small transistor size and low power dissipation of CMOS circuit, demonstration principal advantages of CMOS or NMOS circuits. And so MOSFET digital circuit it uses CMOS based circuits. Okay. Let us understand MOSFET as a switch. See, this is a circuit. You just concentrate on the circuit first. MOSFET as a switch or MOSFET as an inverter we can use. See, this is a circuit. This is MOSFET as a switch. Transistor also can be used as a switch. Do you know? Same way, how the transistor is used as a switch, I am drawing over here. This is a NPN transistor. So plus VCC is there in a NPN transistor, and there will be a ground over here. Then input in VI. If VI is this type of waveform, output V0 is such type of output. Okay, this is a output. If input is this, output is reverse. That means transistor is providing us 180 degree out of phase circuit. Our signal, input signal is 0 or say positive pulse, output signal will be negative pulse, and hence transistor can be used as an inverter and transistor can be used as a switch. Switch is what? Switch is nothing but this is a switch. Your electrical switch, suppose you are making switch on and your tube light glows, that is a electrical switch. What you do, you have a 230 volt supply. See, in the diagram I am drawing, you have a 230 volt supply at the V in, and same is passed to your tube light, which is V0, which is it is tube light. V0 is tube light. What this switch does? It supplies this input which was closed initially, and it gives output to the supply. Same input, whatever input available to the output, it goes to output side. Whatever available to the input, it goes to output side. It is nothing but a switch. That means initially it is closed, it becomes initially it is open, it becomes closed. Now transistor as a switch, it can be used as a switch. That means whatever is there at the input side, the same can be given to the or passed to the output side. Suppose this is a input or positive pulse is there, and as we know that between input and output there is 180 degree phase shift in a MOSFET also, in a transistor also it is 180 degree phase shift. See, this is a transistor base switch V0. Same circuit is there, only replace transistor with FET, that's all. Only replace transistor with FET. This is a switch. That means if in a FET, if we apply a square wave, it goes to base of FET. Base of FET is P, or gate of FET is P. Drain is N channel. Drain is N channel. Do you see? If input is a square wave, say like this, a square wave is applied to gate, then gate is P type of material. So this is a positive input. This is connected to P type of gate. Source is N type of material. So this junction becomes forward biased. As this junction becomes forward biased, current flows through this circuitry. Okay, this junction becomes forward biased and current ID flows from VDD to RD through drain and towards source. It ends up to ground, which is source. As current flows through this, output is measured between drain and source. As current is flowing from this side, voltage will be dropped across ID into RD. Maximum drop will occur across RD because ID is increased. So drop will be across RD and VDD is suppose 5 volt. ID is 5 ampere, RD is 1 kilo ohm. So there will be total, see, it is VDD is equal to 5 volt, ID is equal to say 5 ampere. Assume, 5 milliampere we will say. Okay, RD is 1 kilo ohm, and so current or voltage drop across this ID into RD is 5 volt. Now how much current, how much voltage remain across this? Across drain to source, 0 volt voltage remained, because this 5 is consumed at resistor RD. Voltage drop is developed across RD, and so that 5 volt is consumed across RD itself. There is no voltage drop between drain and source, and so across this there will be 0 volt voltage. So we will say 0 volt voltage means at positive pulse it gives 0 output, or say 0 volt output. During negative pulse, this output rises to positive. During negative pulse, what happens? If input to the gate is negative, then P type of material is gate and N type of material is source. This gate to source becomes reverse biased and there is no IO current flows through this. ID current is 0. 0 multiplied by RD, this drop is 0. So whatever available across VDD, that is transferred to this drain to source, so output becomes positive. Okay, hence we will say that during positive peak I am getting 0 voltage, or say if my input is, if I press the input I am getting 0 output, and if my input is 0 I am getting plus volt. That means as it is but 180 degree out of phase voltage is there. That means you will make a question may arise, it is a reverse, how it is switching. Your question may arise in your mind that it is reverse. That means if it is a positive pulse, at the output side you are getting negative pulse. Okay, so you may think that it is not a switch, but switch is what? Whatever there is, it should be transferred to the output side through a certain switch is what? Switch is this. Whatever there at the input side, it should be transferred to output side. This is a switch and this is FET. this is this side and this is this side. Okay. Input is pulse, output is this side, but it is reverse. You will say that it is not a switch then. But let me to tell you, if in a normal light, in a normal electricity, what happens? If you switch on the supply, it is immediately transferred to tube light. So tube light will glow. So as it is transferred. If your switch is उल्टा switch रहेगा, तो ऑन करने के बाद वो ऑफ हो जाएगा, ऑफ करने के बाद ऑन हो जाएगा. अगर ऐसा स्विच रहा तो दैट इज ऑल्सो ए स्विच. द सेम केस ऑकर्स हियर. ऑन करने के बाद ऑफ हो जाता है, ऑफ करने के बाद ऑन हो जाता है. दैट मीन्स इफ यू मेक ऑन योर स्विच, your tube light will not glow. If you make off your switch, your tube light will glow. That is also one type of switch. It is a reverse switch, we can say, but it can be used as a switch. The same case happens in a FET as a switch. Okay, this FET, so FET can be used as a switch. Now if I use FET as a switch, at the same time I can use FET as an inverter. Inverter means if input is plus, same circuit I can use for as an inverter. FET can be used as an inverter also. See, inverter circuit I will show you. This is a inverter circuit. Same circuit is there. FET can be used as a inverter. Okay. This FET can be used as an inverter. That means same circuit. If input is positive here, I am getting negative output. If input is negative, then I am getting positive output. So FET can be used as an inverter. If input is sine wave, I am getting inverse sine wave at the output side because it is 180 degree out of phase. So FET can be used as an inverter. This is main application. Where is application of inverter? It is in a digital circuit where you require 0 should be converted into 1 and 1 should be converted into 0. So in a digital circuit you need this inverter circuit. So FET based digital circuit can be manufactured using Mosfet as a inverter. So if in a digital circuit, if 1 is a input, output is 0. If 0 is a input, output is a 1. So it is an inverter. So this becomes inverter. Okay. If a question arises in a question paper that it is an inverter, you draw this waveform. That means if VGS is infinity or say 5 volt maximum, then output VDD will be 0. And when VGS is 0, your output is high. This is what a inverter is or transfer characteristics is. So this is a graph to draw in a examination. Output V0, this graph, this is a graph you have to draw in an examination. Which graph you have to draw? You have to draw this graph. This is a transfer characteristics, VDD versus VDS, where VDD is your output voltage and VDS is applied input voltage. If applied input voltage is 5 volt, you are getting VDS is 5 volt, you are getting 0 or reverse output. And as an inverter, you have to draw this circuit. As an inverter, you have to draw this circuit. Okay, understand? Okay. Diode has two terminals and MOSFET has 3 terminals. So, how you ultimate question may arise in your mind that how diode can be used, how MOSFET can be used as a diode. For this, we have to reduce one terminal so that it will be converted into diode. Now, in a MOSFET, this is a symbol of the MOSFET. This terminal is gate. This terminal is this terminal is source. This terminal is drain, and this terminal is gate. If I connect, if I short gate and drain, then N type of material is shorted with P type of gate. Now gate is shorted with drain, and hence only P type of material gate is available. Gate is P type of material and source is N type of material, source. This is P material. A junction between P material remains. Junction between this P material and N material remains, and this will form this type of junction. P material, N material remains. This is gate and this is source. So this forms your diode. Now in a diode, both material, the impurity added in P and N type of material is no doubt different, but it is say 1 parts per million. Here P material is having less impurity added and N material is having N plus impurity added in this. So in a MOSFET based diode, impurity added are different, but the function or the working principle of diode, a MOSFET based diode, remains same. डायोडचे कॅरेक्टरिस्टिक्स काय आहे तर त्याला वेन यू आर कनेक्टिंग इनपुट टू द डायोड, input is this. See, in a diode this is P type, so V in your in a diode you are applying plus 5 volt, then this junction becomes forward biased and you are getting output at the V0 side. So this, if I turn, this becomes diode, P type of material, N type of material, and output is V0. V in is there, V in and V0 output. When you are applying input to V in, input, vary the input across the V in, vary the input, vary it, input V in 1 volt, 2 volt, 3 volt, 4 volt. Corresponding output will be, output current will flow through this. Current will flow through this. Diode is connected across positive and this is across negative, plus and minus. Then current will flow through this in this direction. The current graph is for 1 volt, current is say 1 millivolt. For 2 volt, current will be 2 millivolt. For 3 volt, current will be 3 millivolt. For 4 volt, current will be 4 millivolt. And for 0 volt, current will be 0 volt. But what will be the, if I plot a graph, how it will be? It will follow this path. This will be graph of current voltage, current versus voltage. Current versus voltage graph will be like this. Current will flow for corresponding, if I draw a graph, it will be like this. Here there will be a knee voltage, and corresponding output will change, and after knee voltage, diode, current across diode increases. And this is the characteristic, this is also called the characteristics of diode. The same characteristics you will find if I use separate PN junction diode. So MOSFET can be used as a diode. Such type of active MOSFET is used in a very large scale integration. In a manufacturing of diode in a very large scale integration, MOSFET as a diode can be used. याचाच यूज डायोड VLSI मधला डायोड मॅन्युफॅक्चरिंग करण्यासाठी होतो, हे मला तुम्हाला सांगायचं आहे. आणि हेच ॲक्टिव्ह सर्किट वी कॅन यूज फॉर रेजिस्टर मॅन्युफॅक्चरिंग. त्याच्या ह्या डायोडचं जसं मॉस्फेट कॅन बी यूज्ड ॲज ए डायोड इन ए सर्किट. कॅरेक्टरिस्टिक्स ऑफ मॉस्फेट ॲज ए डायोड तुम्ही समजूच नाही शकणार की प्युअर डायोड आहे का मॉस्फेट बेसचा डायोड आहे. दोन्हींच्या कॅरेक्टरिस्टिक्स सेम असतात. म्हणून डायोड नॉर्मल डायोड इज रिप्लेस्ड बाय मॉस्फेट बेस्ड डायोड. Third thing we will learn, diode can be used as a MOSFET can be used as a resistor. Resistor is a passive component, आणि passive component जेव्हा VLSI मध्ये मॅन्युफॅक्चर करतो इट टेक्स लार्ज स्पेस इन दी VLSI टेक्नॉलॉजी. म्हणून पॅसिव्ह कंपोनंट न यूज करता ॲक्टिव्ह कंपोनंटचा एक रेजिस्टर तयार करायचा आणि तो मॅन्युफॅक्चर करायचा. वी विल मॅन्युफॅक्चर इन ए व्हेरी लार्ज स्केल इंटिग्रेशन टेक्नॉलॉजी. त्याच्यामुळं काय होईल, युअर स्पेस विल रेड्यूस, स्पेस कमी होईल. म्हणून मॉस्फेट कॅन बी यूज्ड ॲज ए रेजिस्टर, म्हणून त्याला ॲक्टिव्ह रेजिस्टर म्हणतात. मॉस्फेट कॅन बी यूज्ड ॲज ए रेजिस्टर. हा रेजिस्टर यू विल फाइंड ए रेजिस्टर इन द सर्किट. दिस इज ए रेजिस्टर, इट इज पॅसिव्ह कंपोनंट. This resistor is a active component. The MOSFET switch can be viewed as a resistor where the transistors drain and source form the two terminals of the floating resistors. आणि त्या रेजिस्टरचा रेजिस्टन्स यांचा रेजिस्टन्स हा फ्लोटिंग रेजिस्टर म्हणजे पोटॅन्शिओमीटर टाईप ऑफ रेजिस्टर. यात दिस गेट इज वर्किंग ॲज ए रेजिस्टर चेंज. म्हणजे यांच्या ए आणि बीमध्ये एक रेजिस्टर असतो. म्हणजे मॅन्युफॅक्चरिंग जर बघितलं तर दिस इज ए एन चॅनल सोर्स अँड दिस इज एन चॅनल ड्रेन. आणि इथं तुमचा गेट असतो. गेट इज दिस इज अ गेट, दिस इज सोर्स, दिस इज ड्रेन. आणि यांच्या दोघांच्या मध्ये पी टाईप ऑफ सबस्ट्रेट असतं की इट फॉर्म्स ए चॅनल. मग याचा इम्पिडन्स असतो, याला रेजिस्टन्स असतो. हा जो चॅनल आहे इट इज ॲक्टिंग ॲज ए रेजिस्टर. रेजिस्टर म्हणून ॲक्ट होतो तो. हा जो चॅनल आहे दॅट इज ॲक्टिंग ॲज ए रेजिस्टर. हेन्स मॉस्फेट कॅन बी यूज्ड ॲज ए रेजिस्टर. आणि हा गेटचं व्होल्टेज इफ आय चेंज दिस व्होल्टेज across this gate then resistance changes. याच्यातला रेजिस्टन्स चेंज होतो. यू गॉट माय पॉइंट. दिस इज अ मॅन्युफॅक्चरिंग. आणि हा गेट, हा ड्रेन, हा सोर्स ड्रेन गेट and again this forms a channel. Channel is resistor. Channel opposes flow of current. And gate, if gate voltage changes, this channel width changes. As channel width changes, resistance also changes, and so this is replaced is resistor, which is nothing but a potentiometer resistance, whose value of this resistance changes based upon gate. And so MOSFET can be used as a resistor. Where these active resistors can be used, these active resistors can be used in a switch. आता हे transistor as a switch, we have studied this circuit. This circuit is transistor as a switch or transistor as a inverter. Now this RD is a passive load. It can be replaced by this load. by this switch. So this is a MOS as a load, active load. This MOSFET can be used as a active load resistor. So active load resistor का फायदा क्या है? According to voltage, current will change. Current will change. Current will flow through this. So MOSFET as a resistor is used here instead of RD. This RD and this MOSFET as a load is there. Okay, so it is used everywhere. In a small circuit analysis, it can be used. We will stop here today. Tomorrow we will see next part. Today only we have studied different characteristics, the different principles of diode. Means what? We have studied MOSFET as a switch, MOSFET as an inverter, MOSFET as a resistor, MOSFET as a diode. We will see next part in the next lecture. This whatever we have studied is very important part in the unit number 2. Okay.